Curves and regions. In the first example, we'll look at a curve, and given that z minus 3 times z conjugate minus 3 equals 4 represents a circle, find the centre and the radius of the circle. I'll just write this out again. Z minus 3, z conjugate minus 3 equals 4. And removing the brackets, we get z conjugate minus 3z minus 3z conjugate plus 9 equals 4. That is z conjugate minus, now I'll put this 3 outside of z plus z conjugate plus, and bring this 4 across. We're going to get 5, aren't we? Equals 0. Now, z is equal to x plus iy, and z conjugate equals x minus iy. So z conjugate must equal the product of these two. And you need to be a little bit careful here. And that becomes x squared. This becomes plus y squared. Now, z plus z conjugate, fairly easy. These go out and you just get 2x. Okay, putting this back in, we have x squared plus y squared minus 3 times 2x is going to be 6x plus 5 equals 0. So this becomes, we'll go up here, x squared minus 6x, leave a little gap, plus y squared, and I'll take that 5 across the other side, minus 5. Now completing the square here, half that number is minus 3 squared, you get 9, plus 9, add it to this side. This becomes x minus 3 all squared plus y squared is equal to 4. So this is the circle, centre 3, 0, and the radius equals square root of 4, which is 2. Done. Now in this next example, we're going to mark clearly on the Argand diagram, over here, the regions of the plane satisfied by the modulus of z lying between 3 and 4, and arc of z lying between pi upon 3 and 2 pi upon 3. Just go back over what this means. We can see that we know that the modulus of z is equal to the square root of x squared plus y squared. So the square root of x squared plus y squared is equal to 4. So x squared plus y squared equals 16. So this is a circle of radius 4, not radius 2. Okay, just to clear that little point up. So this is saying, the first bit saying that we've got two circles. We've got the first one here, that a circle which is less than 4, and here another circle which is greater than 3. So drawing that on the Argand diagram, I can do it fairly accurately. There's my 4, that's too bad, is it? Okay, now the 3. Okay. Alright, so that's 3 there. So that means that if it's less than 4 but greater than 3, it must be all the area in between those two. Alright, now this one, the argument of z, well, arg of z equals pi upon 3 would be a line going that way, wouldn't it? Circle there, arg going, 6 degrees up here. Right. Now, but it says it's got to be bigger than, so it'll be moving in that direction there, the area will be in that direction there. Here it's saying that the argument of z is less than 2 pi upon 3. Well, 2 pi upon 3 is over this side. Over there, from there to there. Right. And it's going to be less than that. So in between there and including this other area you've just drawn, then it must be all this area which is shaded in here. Done.